Hello, everyone. My name is Jose Monsalve Diaz. I am a postdoctoral researcher at Argonne National Laboratory, and I'm going to discuss how we were trying to explore some ideas on how to use OpenMP target offloading in the GraphCore architecture. And in reality, the question that we want to ask is, can we fully support OpenMP in GraphCore IPUs? And the answer is no. The real question that we want to ask is, can we support some of the OpenMP semantics to try to target the IPU cores in the GraphCore architecture? So it's more of an exploratory project. The reason why we wanted to do this is because in Argonne, they have a set of computers, a set of test beds for AI, like GraphCore, NextSilicon, and all these systems. And they wanted to see what would be needed if the scientific applications were able to run or use this system. So how can we make sure that the scientific applications work in there? And many of the scientific applications, they already have OpenMP code, and it would be interesting to see OpenMP's ability to be able to exploit heterogeneity in these kind of systems. So it was mostly a kind of like a big question. We didn't have really high expectations, but we wanted to see if it was just possible. There are going to be 4 modifications that are going to be necessary for implementing this. The first one is we are going to need a backend for the GraphCore IP architecture. We're going to need to modify the front end to be able to take the OpenMP semantics and transform it into that backend. We're going to need a GraphCore plugin into the OpenMP runtime, and we need a clamp driver that will drive the execution of all that. So fortunately, on the backend side, the PopC compiler, that is the compiler that they use, is already LLVM based. We had to tweak a little bit with it to be able to understand how to input LLVM IR into it, but we discovered that it was possible to create LLVM IR that was compatible with the IPU. The front end, the most important question here is, how do we map the different semantics of the OpenMP world into the semantics of the IPU systems? So we need to consider Vertex, compute sets, Tensors, IPU programs, and mappings. So the first part is, how do we specify the vertex? We can use the OpenMP tasks, and we use the depend out to be able to specify the variables that are going to be coming into the codelet. The second one is, how do we specify the compute set? The compute set is a set of tasks that can execute completely in parallel to each other. And in here, what we think is a good idea is to use the parallel regions with a specified set number of threads, and then extend the mask clause in OpenMP to be the mask directive in OpenMP to be able to filter the number of OpenMP tasks that we want to create for each. Then for the tensors, we believe that it is possible to take some of the already existing types that are supported by IPU, and whenever we have a target map region, we are able to just create tensor descriptions of those variables into the device. And if we have the definition of elements within the device, we should be able to create tensor descriptions of that. Then for the next part is the IPU program. It's a control flow program that drives the execution of the different elements in the IPU, in the GraphCore architecture. So what we propose is use the control flow structure of the program within the target region to be able to create the equivalent in the IPU program. This is all done through the library calls in the IPU programming interface. The third part will be the plugin. Here is where we mostly use the already existing Poplar library to be able to access all of the features of the device. We would provide the Vertex created from the front end, and then allow those to be loaded into the device. And then the IPU program will come and try to go and execute the device. So here is where we keep track of the device state and whatnot. And the final step is the driver, where we put everything together. Here is just an example on how we can actually call the PopC compiler to be able to pass the LLVM IR created by the front end into the PopC compiler, and then from there we pass it to the OpenMP runtime. This is not a complete project right now. This was just an exploratory idea, and we wanted to understand the possibilities of doing so. But if you have any comments, suggestions, or questions, feel free to reach out. Thank you very much.